Now let's take a look at the most commonly used generators. For their work, generators need additional child objects. Based on these objects, new geometry will be created. All generators are marked in green. They can be found in the command bar or the main menu. Subdivision surface objects require polygonal objects or primitive objects to work properly. Going ahead, the extrude, rotate, loft, and sweep generators use splines. And a little side note. Generator objects do not have points or polygons of their own, so conversion is used to refine them at the polygon level. But if you add a correction deformer, you will have access to points, faces, and polygons by selecting the appropriate mode. Let's go back to subdivision surface. Generators, like other objects, have tabs with parameters and settings. The first two tabs are exactly like those of any other object. The most important thing is in the Object tab. The subdivision surface object subdivides the surface of objects and rounds them. The subdivision of polygons is set by the parameters subdivision editor and render, which adjusts the subdivisions in the viewport and in the render accordingly. This is done so that you can set a high-quality subdivision for the render and not load the model in the viewport. By setting the value to 1, each polygon in a model will be split into 4 new polygons. By setting the value to 2, it is split by 16, and so on. It makes no sense to set a value higher than 3, as this slows the program very much. Note, the closer the edges are, the less rounding between them will be. We'll talk about this later on modeling for subdivision. Consider the next parameter. The Type tab has various subdivision settings. Usually the default type is used. The Subdivide UVs parameter is the setting for how the UV coordinates should be changed when divided. This generator acts only on the first sub-object of the hierarchy. In order to influence several objects with one generator, you need to place them in the Connect generator. We'll talk about it a little later. But it looks like this. The next generator is Cloth Surface. It is used to create thickness for flat objects, most often for creating fabrics. The thickness parameter is responsible for this. The subdivision parameter is responsible for subdividing polygons, as in the subdivision surface generator, but does not apply anti-aliasing. To make a fabric simulation, you need to convert the model into a polygon object and apply the cloth tag. Selecting the desired object, right-click, go to Simulation Tags, select the cloth tag. Next, select the object that will interact with the fabric. Apply the Cloth Collider tag. Now, if we animate it, we can see how the fabric simulation works. Connect generator. As I have already shown, this generator allows you to combine several objects in order to be able to influence them with one generator. For the generator to work, you need to attach child objects to it. Or, if you already have a group of objects, you can put the parent object of the group in the objects line. The generator will affect all objects in the group. The generator can also merge the model together. For this, you must have the Weld button enabled. The distance at which they start to merge is adjusted by the tolerance parameter. Phong mode determines the level of smoothing of the merged objects. Texture function. If the checkbox is unticked, the materials of the models are not taken into account in the Connect generator. When checked, they do. Center axis. It positions the interlocking objects at the origin of the connect generator. Instance generator. This is a super cool thing. It comes to rescue when you need to create many identical objects. Instance is a duplicate of the original object specified in it. But at the same time, it does not have its own geometry. Create an instance and a platonic object. We see a red cross next to the generator, which means that we need to assign an object we want to duplicate to it. Add our object to reference object. Open the parameters of this object by clicking on the arrow. I will create several duplicates of the instance object. Let's go back to the platonic object. Let's change its settings. And we see that all instance objects accept these changes. This allows you to quickly edit a large number of objects. The instance has several modes. Instance is a full-fledged duplicate of an object. It requires as much system memory as the original object. In this mode, we can influence them with deformers and add them to generators. Render instance. This mode allows you to create a large number of copies using MoGraph, without slowing down the system very much. This mode has a number of limitations. With it, you cannot use generators and deformers. I'll create a cloner and place it into instance. As I said, in this mode, you can create a large number of clones that will not slow down the system too much. And the last mode is multi-instance. It allows the generator to interact with the standard particles and matrix object. I'll create a particle object. Go to instance and add emitter to the position's source parameter. Let's play the animation and see that the particles are created based on instance. Symmetry. The symmetry object is of particular importance when modeling polygonal objects, since it will be enough to make a part of the model and then mirror it. Symmetry works about its center of coordinates. Let's add a child object to it and see how the generator works. Now nothing happens because the center of the object's symmetry and the model coincide, and the symmetry along the XY plane mode is turned on. If we offset the object, we will see that it is mirrored. By changing the plane, we mirror the object from different sides. Try to always create objects in the center of coordinates. It will be easier to adjust it. The generator has a merge point function. Let's create a half of a polygon model for demonstration purposes. When the weld points checkbox is ticked, the nearest points are merged. The tolerance parameter adjusts the merging distance between the points. Symmetrical is responsible for merging the points symmetrically. Bool. This generator performs Boolean operations for parametric or polygonal objects. It needs two objects to work. They are added to the generator as child objects. By default, A subtract B mode is active. A is the top object in the hierarchy, B is the bottom one. We add the objects to the generator, but nothing happens. It happens so because the objects must intersect. I will move the primitive a little higher. Modes. A union B. This mode combines objects into one model. This is clearly visible in the X-ray mode. Let me remind you that you can enable it here in this panel. If you turn the generator off, you can see that the objects are disconnected. The next mode is A subtract B. Object B is subtracted from object A. Mode A intersect B displays the part that is intersected by the models. Mode A without B. In this mode, a hole is created in object A by object B. Create single object. If we now convert the object into a polygonal model, we'll create two parts of it. When the create single object function is enabled, a solid model is created. Hide New Edges mode hides new edges and creates an n-gon polygon. The next, Generators tab. These generators are related to spline modeling, so we will talk about them in the next lesson on this topic. The following generators are Volume Builder and Volume Mesher. Volume Builder is the generator that allows you to create voxel objects from all types of Cinema 4D objects. Let's create a couple of objects to add to the generator. Add objects to the generator. They appear under the Object tab. Volume Builder has several modes. Most often the default one is used. The voxel size parameter is responsible for the size of the voxels generated by the generator. Too small a value for this parameter can slow the program down, so be careful. Pay attention to the objects. We see sharp edges because the Volume Builder does not take the Phong tag into account. To create a more accurate geometry, you need to add subdivision to the models. The SDS Smooth tool is designed to smooth voxels. It has several anti-aliasing modes, but the most optimal ones are Gaussian and mean. The mean operator preserves the shape of objects better. The parameters voxel distance and iterations are used to adjust the smoothing. It has a Field tab, which means you can customize the object's anti-aliasing area. Now it is not very noticeable, but it will be more visible in a Gaussian mode. I'll delete Field and return the old statement. Boolean operations can be performed on the objects in this list. To this list, you can also add objects that are not available in the Volume Builder. To do this, just drag and drop an object to this list. To apply anti-aliasing to it, place it under the smoothing object. Now you can perform various operations, but as you noticed, the original object is now visible. You need to turn it off in the viewport and render. Don't forget to add subdivisions on objects to achieve smoother shapes. We've got this model. For a more convenient hierarchy, use folders. Boolean operations can also be performed with them. The voxel model is ready. Now you need to convert it into mesh. For this, we need a volume mesher generator. It generates a voxel-based polygon mesh from the Volume Builder, which needs to be a child object. Turn on the display of polygons. We see a very detailed mesh, but we can make it less detailed. Go to the Volume Mesher generator. It has two settings. With the first slider, we can adjust the position of the polygonal surface between the existing inner and outer layers of the voxel. Usually this value does not change. And the adaptive parameter allows you to reduce the number of polygons. Unfortunately, the mesh is very often bad in some places, but it can be edited at the polygon level if there are not too many polygons. There is another solution, which is to use the Quad Remesher plugin. It is great at converting such a complex mesh into a more or less correct mesh. To do this, we convert the Volume Mesher object into a polygonal model. Click the Remesh It button in the plugin and it creates an object with an improved topology. Naturally, it's not perfect, but it's way easier to adjust it. To compare them, I'll place it side by side with the original model. This plugin is paid, but you can download a demo version and test it. A link to it will be in the description of the lesson. On the website, you will need to go to the Quad Remesher tab. Select Download and provide your email address in this line. You will receive a link to the demo version of this plugin by email. Let's go back to the Volume Builder. There is one important point. For generators to work, objects must be closed. If I add an open object in the Volume Builder, at first glance, nothing terrible happens. But when we apply smoothing, the object disappears. If we close the polygon again, this will work fine. Volume Builder also works with splines. Let's create an object. By adding it into the generator, we get a 3D model. If I reduce the voxel, we can see that spheres are created along the splines. Their settings are accessible here. We can change the size of the spheres and adjust their density. As well as for regular objects, we can add anti-aliasing to them. After adjusting all the parameters, create a volume mesher. We add this generator to it. This is how you can create various tricky shapes. Let's move on. MoGraph is a set of tools for procedural modeling and animation. It includes various generators and effectors. Generators are green and effectors are purple. Let's take a look at the cloner generator. Cloner is the main one in MoGraph. In order to create clones, you need to drag and drop a child object into the generator. The first two tabs of MoGraph objects are the same as the rest of those of Cinema 4D objects. The Object tab has generator settings. The generator has several modes. Each mode has its own settings. Let's start with the linear one. We can adjust the distance between the clones, change their size and rotation. The count slider controls the number of clones. The offset allows you to offset, but only in the positive direction. The next mode is radial. It has settings for the radius, number of clones, and position. There are clone restrictions as well as offset and small randomness. The grid array mode allows you to create blocks of clones. The number of clones is adjusted along the 3-axis. The distance between the clones is set by these parameters. The from parameter allows you to create clones in the form of simple shapes or a custom object. To make this form readable, you need to adjust the number of clones and the distance between them. The honeycomb array mode has settings for adjusting offset, the number of clones along 2 axes, and the distance between them. It also has the from parameter. The function of adding a spline is available in this mode. Let's create a spline. Let's add it to the line. The last generator mode is Object. When this mode is selected, a line appears where you need to add an object. Clones will be created from this object. Let's create a torus. We drag and drop it in the object string. Clones of cube are randomly created from the torus object. Now the cube is pretty big. I will make it smaller. This mode has settings for the number of copies and a parameter that changes their position. The distribution parameter determines how clones will be created from the model. By default, surface mode is selected, which randomly distributes copies. In the vertex mode, copies are created exclusively from mesh points. So the number of copies will depend on your model's level of detail. In the edge mode, clones are created in the center of each edge, and the polygon center respectively at the center of each polygon. The volume mode fills your model with clones, but you need a large enough number of clones for this to be visible. Axis mode creates a clone in the center of the object. Now let's talk about the hierarchy in the cloner. Let's create some objects and add them to the generator. I will place them in a radial mode. I will adjust the position and number of copies. The clones parameter has several modes for making copies. For convenience, enable the display of the clone index. To do this, go to the Transform tab and select Index in the display parameter. All cloners now have indices. The topmost cloner in the hierarchy is considered a null cloner. If I swap the objects, tube becomes the null. So, iterate mode is the default one. It arranges the clones in order, just as they are in the hierarchy of the cloner object. By choosing the random mode, the clones will be placed chaotically. The seed parameter changes their variation. The blend mode is clearly visible when we have one object with different settings, and this mode makes a smooth transition between them. I will remove all objects. I will leave only the cube in the generator. Duplicate it. Resize it. Now you can clearly see the transition between these two objects. And the last mode is sort. Now it creates clones of only the first object, that is the 0, 1, judging by the index. In order for the mode to work, let's add an effector. I will be using an effector shader with a gradient. Place the effector into the appropriate tab. I add a gradient in it. And now, for it to work, go to the Parameter tab and increase the value to 100% of the modified clone parameter. Set up the cloner a bit to show all kinds of copies. I return to the gradient, changing it. We can see how the clones are located. Let's consider a few more effectors. Let's create a torus object and place the clones over it. Now go to the Effectors tab and add Push Apart. This effector pushes clones away from each other. Let's adjust the radius of this action. In this way, you can slightly raise the clones from the object, so that it seems that they are lying on the surface. This effector has another mode that allows you to reduce the size of clones if they are close to each other. I will duplicate the effector and name it Scale Apart. Select the appropriate effector mode and place it to the Push Apart effector in the cloner. We get the following effect. Let's consider another effector. It's called Plane. I'll set up the cloner a little differently. By adding it to the cloner, we see that the copies have shifted. Let's move on to the plane settings. It has parameters that can influence bevels: position, scale, rotation. For example, I will randomly configure these parameters. Now I will add field in the falloff tab. Moving the field object, we can see how the clones have changed. In this way, you can create animations. Let's add the random effector here. It also has changes in the position, scale, and rotation parameters. I will customize them. And now comes the fun part. Go to the falloff tab and add the linear field, which is located in the plane object. We got the ability to control two effects with one field object. It is super convenient. Next, let's talk about the matrix generator. The matrix object is almost the same as the clone object, so its settings have common parameters with the cloner object. As well as in Cloner, you can create matrix objects in the form of cubic, sphere, cylinder, and an arbitrary object. For example, let's create a platonic object and place it in the Object tab. Copies are created for this object. This generator also has a clone index display. A tab for effectors is also present. Now, the most obvious difference between Matrix and Cloner is working with modifiers. Create a twist modifier and apply it to the matrix. All clones have no distortions, and everything works well. Now let's create a similar thing, only using the Cloner generator. In order to apply the deformer, the generator must be placed in a null object. Set up the deformer. I'll apply the deformer to the cloner generator, and we see that all the clones are deformed. This option is not suitable. But on the other hand, we cannot assign our own model to the matrix object. The solution is that we convert the cloner to the object mode, place the matrix object in the appropriate tab, and everything works as it should. And finally, let's cover the Voronoi generator. It allows you to destroy objects. Fragments can be further modified using the MoGraph effectors. An object can be made editable at any time using the C key. That is, all fragments will be grouped as separate ones. For example, create a cube, add it to the generator, and add the push apart effector to slightly change the initial shape and show you how the effector affects this generator. You can also apply dynamics by adding tags. But first, let's create a plane on which the object will fall and destroy. Add rigid body to the generator and collider body to the plane. Let's play the animation. We see a rather spectacular destruction. So we've examined all the primitives, deformers, fields, generators, and got acquainted with MoGraph. Now let's create some models to cement our knowledge. The next part of the lesson is practical. In it, we will create several models using primitives, deformers, and generators.